Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class we are going to discuss a numerical on the topic analysis of perfect frames by using any one of the analytical method such as method of joints and method of sections. This numerical we are going to solve by using both the methods. Okay. And then very important thing to solve this numerical, some basic knowledge on the topics, principle of transmissibility, moment principle, equilibrium. Okay. So some basic fundamental concepts are required. That and all discussed in a separate video. That video link is given with the description box of this video. Okay. So it's better if you have any doubts on that basic fundamental knowledge which is required to solve this numerical, it's better to watch that video which is given in the description box. Okay. Let's go to the numerical. The truss ABC shown in figure has a span of 5 meter. It is carrying a load of 10 kilonewton at its apex. Find the forces in the members AB, AC and BC. Okay. Here a truss ABC is given. It has a span length 5 meter. It is loaded with a value of 10 kilonewton at its apex. We named that apex as A. Okay. We have to find the forces in the members AB, AC and also BC. Okay. So here this truss is supported at both the ends B and C. It is simply supported. So at point B and C, the reaction forces will act. That is the RB and RC. These two are the unknown forces which is required to be calculated. Okay. So here we can consider there are 3 point loads are acting. At point A, 10 kilonewton. Point B, the reaction upward force RB is acting. Point C, the upward reaction force RC is acting. Okay. So the first thing we have to calculate the reaction values RB and RC. Okay. So the equilibrium principle, summation of vertical zero, summation of moment about any point equal to 0, that things and all we can use. Before that, we have to calculate the distances. That means the 10 kilonewton. Here, the 10 kilonewton is considered or it is acting at point A. But as per the principle of transmissibility, we can consider or otherwise the line of action of the force 10 kilonewton which is acting at point A, that we can consider it is acting along the line, because this is the line of action of force. That means line of action of the force in which the 10 kilonewton is going to act. Okay. So we can consider this 10 kilonewton may act at any point along its line of action of force. Okay. That means we can consider it is acting at point A even it is acting at point D also. Okay, this point, if you consider as D. Okay, so this distance AD, BD, that we have to calculate, and the vertical distance AD, that also we have to calculate. Okay, so here there are two right angle triangles we can consider. That is ABD, that one is the right angle triangle. ACD, that is another one right angle triangle, or we can say ADB, ADC. So the right angle triangle ADB, okay, in this right angle triangle, I'm going to take this BD as X. Okay, I'm going to take the BD as X. Okay, that means this distance from the point B to the point D, this distance I'm going to take as X. Then we know that this distance from point D to point C, okay, this one we can consider as 5 minus X. Okay, from the point B to C, that is the total distance 5 meter. From point B to D, if you consider that is X, the remaining distance DC, that will be the total distance 5 minus this X, that will be 5 minus X. The same way the AD, that I'm going to take as Y. Okay, so here in this right angle triangle ADB, I'm going to calculate tan 60 degree. Okay, that is tan 60 degree, which is equal to opposite side divided by the adjacent side. That means we can write Y divided by X. Okay, then we can write X equal, or otherwise Y equal X tan 60 degree. Okay, then from the right angle triangle ADC, okay, I'm going to calculate turn 30 degree. This also opposite side divided by the adjacent side. Here the opposite side is same AD divided by the adjacent side, that is CD. Here AD, that is Y, divided by the value of CD is 5 minus X. Okay, so from this we can calculate, or we can write Y, that equal to 5 minus X multiplied with tan 30 degree. Okay, 5 minus X multiplied with tan 30 degree. This I'm going to take as equation 2. Already we calculated Y equal X tan 60 degree, that equal to the first equation. Here this also Y and this also Y. So we can write equation 1 equal to equation 2. If you equate both the values, we can write, that means here the LHS value Y and Y, so the RHS value will be equal. So X tan 60 degree, that equal to 5 minus X tan 30 degree. Okay, now I'm going to substitute the values of tan 60 and tan 30 in this equation. X tan 60 degree, we can get 1.732 that equal to 5 minus x tan 30 degree, that is 0.577. Okay. So if you multiplied, you will get 1.732x, that equal to 5 into this value minus x into this value. Okay. So 5 into this value, 0.5 multiplied with 0.577, we will get 2.887 minus x into this value, 0.577x. Okay. This minus 577x, we can keep at the left hand side. So it will become 1.732x plus 0.577x, that equal to 2.887. So if you add this two value, we will get 2.309x, that equal to 2.887. So from this, we will get x equal 2.887 divided by 2.309. So by simplifying this 2, we will get x equal to 1.25 meters. Okay, x equal to 1.25 meters. Here we got the value of x. Then if you substitute in any one of the equation, either equation 1 or equation 2, we will get the value of y. That means this value AD we can calculate. Okay. So by substituting the value, I'm going to substitute here. By substituting the value of x, okay, substitute the value of x in equation 1 or 2. Here I'm going to substitute in equation 1. So we will get y equal x tan 60 degree. So y equal the value of x, that is 1.25 multiplied with tan 60 degree, that is 1.732. We will get y equal 2.165 meters. Okay. So the value of x and y that we calculated here. Okay. So which is required? That means these two values are required to calculate the reactions. Okay. Now I'm going to calculate the reactions. Okay. That is reaction calculations. Okay. Reaction calculations. Okay. So here, if this truss with the 3-point loads, 10 kilonewton at A, or B at B, or C at C, then the assumption is with this loading, the truss should be in equilibrium. If this is in equilibrium, then we can use any one of the equilibrium principle. Summation of vertical forces equals 0. Summation of horizontal forces equals 0. Summation of moment about any point equal to 0. Okay. Here there is no horizontal forces. So I'm going to consider the other two principles. That is algebraic sum of the vertical forces equal to 0. Here, there are 3 forces are there, vertical forces, 2 upward forces, RB and RC. Okay. So, based upon this, we can put either upward forces as positive, downward forces as negative, then equate to 0, or upward forces equal to the downward forces. That is, the addition of the upward forces RB plus RC that equal to the summation of the downward forces. Here only one downward force is there, that is 10 kilonewton. This is the first equation here. Then here there is no horizontal forces. So I am going to take the moment about any point, say from B, that equal to 0. When you take moment about, here you can see moment is the force multiplied with the perpendicular distance between the point where the forces is going to act and the reference or considered point. Okay. So here, when you take moment about B, among these three forces, the moment made by the forces in which the line of action of the forces going to pass through the point B, that can be eliminated. Like RB, that is exactly acting at point B. So there is no perpendicular distance here. So moment due to the reaction RB, when you take moment about B, that will be eliminated. So moment made by the other two forces. Okay, here you can see RC is an upward force. The perpendicular distance, that is 5 meter from RC, and then the considered point B. This RC and this 5 meter, okay, with respect to the B, it is a counterclockwise, okay, because RC is an upward force. Here, this is the distance 5 meter or span length. With respect to the B, this RC into 5, that will act in counterclockwise direction. Okay, counterclockwise. So here also the same concept. Either you can consider any one of the direction, like counterclockwise as positive, clockwise as negative, then algebraic sum equal to 0, or counterclockwise moments equal to the clockwise moment. Like that we can do. Okay. So counterclockwise moment, that is RC multiplied with 5, that equal to here 10 kilonewton. As I mentioned earlier, this may act, or this can be considered as acting at point D also. So this 10 kilonewton is acting through, or that means through this line. Okay. So 10 kilonewton, that's a downward, and the distance between the point D and B, that is X. So 10 kilonewton multiplied with X, okay, that will be a clockwise. It's a downward, so that will be a clockwise. Okay, that means this is a counterclockwise moment that can be cancelled or counterbalanced by 10 kilonewton multiplied with X. The value of X we calculated as 1.25. Okay. So by simplifying this, we will get the value of RC that equal to 2.5 kilonewton. Okay. Then substitute the value of RC in this equation 1. Then we will get, that means this is the second equation. Substitute the RC in first equation. That means 10 minus 2.5. We will get RB that equal to 7.5 kilonewton. Okay. So we calculated the values of reactions RC and RB. Okay. Now we are going to do the method of joint first, then method of sections. Okay. So first, method of joints. Okay, we are going to analyze by using the method, that is method of joints. In method of joints, we are going to analyze each joints like B, C, A. Okay, it's better first consider the joints at the corners. Okay, that means start with the free body diagrams and then analysis of the forces of the joints in the corners. Like first from B, C, then go to the interior joints. Okay. And among the three equilibrium principles, such as summation of vertical equal to 0, summation of horizontal equal to 0, summation of moment about any point equal to 0, in method of joints, we will consider the first two by using summation of vertical forces equal to 0, algebraic sum of the horizontal forces equal to 0. Okay. So here, first I'm going to analyze the free body diagram of the joint B as I mentioned earlier. Okay. First start with the joints in the corners. Okay. Free body diagram of joint B first. Okay. So here, first thing, that means what are all the forces or acting at point B that we are going to consider. At point B, a reaction force or B that is acting in upward direction. The tension in the member AB that is acting an angle 60 degree with respect to the horizontal, but this is acting either away or otherwise, yes, either outwards from the point B or inwards to the point B. Okay, that we don't know, that we have to calculate. That is the direction, magnitude, and also the direction. Say the same tension in the member BC. It may act outward, such as from the point B, or otherwise, it may act inwards also. Okay, so that unknown direction, that also we are going to calculate. Okay, so first for point B, consider what are all the forces or acting at the point B. That is the free body diagram. Here first we know that the reaction force or B, okay, the value we calculated, the value of RB, that is 7.5 kilonewton. The value of RC, that is 2.5 kilonewton. Okay. So here RB, an upward force is acting. Then tension in the member AB with respect to the point B. Okay. The tension in the member BA. As I mentioned earlier, it may act either outwards from B or otherwise inwards to the B. Okay, that is not yet calculated or found. Then the tension in the member BC. Okay, tension in the member BC. So these are all the unknown forces we have to calculate when you considered the joint B. Okay. So first thing, as I mentioned earlier, summation of vertical forces equals 0. That also we can calculate. summation of horizontal forces equal to 0. That also we can calculate. First, I am going to consider summation of vertical forces equal to 0. Okay. If this entire joint, that means here, each joints B, C, A, everything should be in equilibrium. Okay. Same, the joint B also should be in equilibrium. Okay. Here, summation of vertical forces. Here, RB is an exactly a upward force. But the TBC, that is an horizontal force. Okay. So the TBC cannot counterbalance the upward force RB. So the upward force RB should be counterbalanced by this inclined force TBA. Okay. But as I mentioned earlier, there are two possibilities for the tension in BA. Okay. That is identifying the direction of TBA. It may act upwards. Okay. If I consider it is upward, then we know that the tension in BA, if this is upward with respect to the horizontal, this angle is given as 60 degree. So we will resolve this inclined force into two components, like TBA cos 60, that will act towards right side, because if we consider this TBA is acting outwards from B, this will be in the first quadrant. Okay. So TBA cos 60, that will act towards right side. TBA sin 60. Okay. TBA sin 60, that will act upwards. Okay. So now this RB, that should be balanced by the resolved vertical component of this inclined force TBA. That means the RB should be counterbalanced by TBA sin 60. Okay. But if you consider this TBA is acting outwards from the point B, that means if it is acting, if you consider as this TBA is acting in the first quadrant, then the TBA sin 60, the resolved vertical component, that will be upwards. Then RB is also upwards. So this TBA sin 60 cannot counterbalance the upward force RB. So this TBA, that cannot act this direction. Okay. So this we are going to eliminate. Okay. So then, if you consider the next possibility, that is this TBA, this is acting inwards to the B. Okay. It is acting inwards to the B. So this will act in the third quadrant. Okay. This will act in the third quadrant. This is TBA. Then the resolved vertical component TBA sin 60, that will act downward. TBA cos 60, that will act towards left side. Okay. So here, when you consider this TBA sin 60, the vertical resolved component of this force TBA, that is acting exactly downward, that can cancel or compensate the upward force RB. So now here, the TBA, that should act inwards to the B. That means this one will be the right, this one will be the wrong. Okay. So we consider the direction of the TBA, that is inwards to the B. Like that, we have to identify the direction of the forces also. Okay. So now summation of vertical equal to 0. So the RB, the upward force, that equal to the downward force, that is the vertical resolved component of the inclined force TBA, that is TBA sine 60. Okay, TBA sine 60. Okay, so from this we can calculate TBA, that equal to RB divided by sine 60 degree. We know the value of RB and then sine 60. So we can get TBA. Okay. That means we will get the value of TBA. Okay. Here, by the calculation, the TBA equal 8.66 kilonewton. Okay, 8.66 kilonewton. Then the direction. Here you can see it is acting inwards to the B, same inwards to the A. So the force in the member AB, that will be tensile in nature. Okay, there are two natures are there. It may be a tensile or compressive. So here it is tensile. Okay. Then summation of horizontal forces equal to 0 in the same joint to calculate the force in the member TBC. So now this inclined force TBA with an angle 60 degree, that is resolved into two component. TBA sine 60, that compensate the upward force RB. So this TBA cos 60 degree, which is acting towards left side, that should be compensated by the another horizontal force TBC. Okay. If this component or the horizontal component of TBA that is acting towards left side, this TBC should act towards right side. That means outwards from the point B. Okay. So for summation of horizontal forces 0 in this joint, we will write TBC, that equal to the horizontal resolved component of the inclined force TBA. That means equal to the TBA cos 60 degree. Okay. Here we got the value of TBA, that is 8.66. So if you substitute the value, TBC equal to 8.66 multiplied with cos 60, that means 1 by 2. So we will get TBC, that equal to 4.33 kilonewton. Okay. So here, this tension in the member BC, that is acting towards right side or outwards from the point B. Same way, it will act outwards from point C also. Okay. So here you can see this force in the member BC, that will be compression in nature. Okay. This will be compression in nature. Here, this will be tension in nature. Okay. So now we are going to analyze the next joint, that is free body diagram of the joint C. Okay. Here, the forces in the members AB or BA, that is calculated. AC, that is not yet calculated. BC, that is also calculated. So only we have to calculate AC. So it's better you can take the joint A or C. Okay. Now I'm going to take the joint C. Okay. So free body diagram of joint C. Okay. Free body diagram of joint C. So here, first I'm going to draw the free body diagram of joint C. Okay. Here you can see this is joint C. So the upward force at point C, that is RC, and the other two forces in the members AC and BC. Okay. Here, the forces in the member AC that may act either upward, that means outwards from C, or inwards to the C. That direction we have to calculate. And it is acting 30 degree to the horizontal. Then the horizontal force in the member, tension in the member BC. Here the direction already we calculated and the value also we know. Okay, TBC, that is 4.33 kilonewton. Here this angle, that is 30 degree as mentioned in the diagram. So here, as mentioned earlier, the TAC that may act inward to the C or outward to the C. If it is outward, okay, then you will get the result like this. Okay, like TBA sine 60 that act upward, that cannot cancel the upward force RB. Same way, TAC sine 30 that will act upward, that cannot cancel the upward force RC. So this should act downward or inward to the C. That means in the second quadrant. Okay. So the tension in the member AC that is acting inward to the C, then the vertical resolved component TAC sine 30 that will act downward, and TAC cos 30, that is the resolved horizontal component of the inclined force TAC that will act towards right side. Here, the TAC cos 30 that is acting right side, TBC, the known force that is acting left side. So from this, we can take the summation of horizontal forces equal to 0. So the TBC, the force which is acting towards left side, that equal to the TAC cos 30 degree, which is acting towards right side. So from this, we can write TAC that equal to TBC divided by cos 30 degree. If you substitute the value of TBC, 4.33 kilonewton, then cos 60 degree, then we will get the value of the tension in the member AC that equal to 5 kilonewton. Okay, tension in the member AC that equal to 5 kilonewton. And here you can see from the direction to the point C, it is acting inwards to the C. Same At point A also, it will act inwards to the joint A. So the force in the member AC, that will be tensile in nature. Okay, that will be tensile in nature. So this is the force in the member AC, the tension or force in the member AC, that is 5 kilonewton. This is the force in the member BA. Okay, and this one is the force in the member BC. Okay, now this we calculated by using method of joints. Okay, the same thing we are going to calculate by using method of sections. Okay, method of sections. Okay, in this method of section, we are going to use the third principle, that is summation of moment about any point equal to 0. Okay, and then here we have to consider the section line. Okay, the section line which intersects the members A, B, B, C, and then the section line we can consider maximum it can cut 3 members. Okay, preferably up to 3 members. So here I am going to consider the section line 1, 1 like this. Okay, the section line 1, 1 which cuts AB and BC. And then this section line separate the entire truss into 2 portions. Okay, left portion to the section line or right portion to the section line. Here I am going to take the left side portions to the section line 1, 1. Okay, I am going to consider the left side portion to the section line 1, 1. Okay, to the section line 1, 1. Okay, here I'm going to draw that segments separately here, that is the tension in the member AB, tension in the member BC, and then the vertical upward force or B. Okay, only these 3. Now I'm going to take the moment about the points C and A. Okay, so first I'm going to take the moment about C and equate that to 0. Okay, so we will get, when you take moment about C, here there are 3 forces are there, such as RB, TAB and TBC. As per the principle of transmissibility, to know what is principle of transmissibility, to see the video for the reference video, the link of the video is given in the description box. Okay, so as per the principle of transmissibility, the tension in the member BC, that is passes through C. Okay, so the moment due to the TBC that will be eliminated. Okay. So when you take moment about C or B multiplied with 5, or B is an upward force multiplied with 5. So this will be in clockwise direction. Okay. That is or B multiplied with 5. This is a clockwise moment. So this should be balanced or counterbalanced by a counterclockwise moment. Here, this TBC that is already eliminated when you take moment about C. So this moment, the moment made by the upward force RB, that should be compensated by the moment made by the TAB. Here also there are two possibilities. It may act upward, that means outwards from point B, or inwards to the point B. If it is outward from point B, that in the method of joints, we discussed that it will act in the first quadrant. The TAB, okay, the TAB sine 60, that also will act this direction. So with respect to C, TAB, if it is acting upward, then that also clockwise. Okay. So it will not act outwards from AB. Okay. So it should act inwards to the point B. If it is acting inwards to the point B, then the vertical resolved component, okay, if this is TAB, the vertical resolved component TAB sine 60, that will act downward. TAB cos 60, the horizontal resolved component, that will act towards left side. Here left side means here this is TAB. Okay. If this is TAB, so here this TAB cos 30, sorry, cos 60, that will act towards left side, and that is also passes through the point B. Okay. The vertical that will act downward like this. Okay. TAB sine 60. But the TAB cos 60, that line passes through the point B. So moment made by the horizontal component TAB cos 60, that can be eliminated. Okay. So this alone eliminated. So moment due to the TAB sine 60, this is a downward force. So the downward force multiplied with 5. When you take moment about C, if it is downward, then that will be in counterclockwise direction. Okay, that will be in counterclockwise direction. If this is B, from the point B, here C is there. This distance is 5 meter. Okay, from the point C, TAB sine 6T multiplied with this 5, that will be in counterclockwise direction. Okay, so TAB sine 60 multiplied with 5. Okay. So now we can cancel this 5 and this 5, and we can write. That means this will be a counterclockwise moment. So we can write RB that equal to TAB sine 60 degree. From this we can write TAB equal to RB divided by sine 60 degree. We have the value of RB and sine 60 degree. If you substitute the tension in the member AB or BA, we will get 8.66 kilonewton. Okay. Here you can see, if this is downward, and that means this AB that is acting this direction inwards to the B, same way that will act inwards to the point A. So forces in the member that will be tensile in nature. Okay, this will be tensile in nature. Okay, we calculated the tension in the member AB. Now we are going to calculate the tension in the member that is BC. Okay, so for that, previously we calculated moment about the C and equate to 0. Now I'm going to take the moment about the joint A and equate to the 0. Okay. When you take moment about A, among these three forces, okay, that is these three forces or B, okay, the three forces or B TBC, okay, or B TBC and TAB. Okay, among these three forces, the moment due to the force TAB that can be eliminated, since as per the principle of transmissibility, the force in the member TAB that passes through the point reference point A. Okay, so the moment made by the tension in the member AB, okay, this one can be eliminated. Okay, so when you take moment about the joint A, we have to consider only these two forces, upward force RB and then TBC. Here you can see this force RB that is acting exactly vertical, and this is acting this way. Do you understand? We can consider this RB is acting upwards along this line. Okay. And with respect to the point A, this is the distance which is equal to the same distance X. Okay. This BD that equal to this distance. Okay. We can consider RB that is acting along this line. With respect to the point A, this distance equal to the X. So RB multiplied with this X with respect to the A or B that is acting here, we can consider this is acting here, or B multiplied with X. This is acting in clockwise direction. Okay, or B multiplied with X, or B multiplied with X, that is 1.25. This is acting in clockwise direction. So this should be balanced by another counterclockwise moment. From the point A, this BC, it may act either outwards from BC or inwards to the BC. If it is acting outwards with respect to the point A, okay, this distance Y. So this tension in the member BC with respect to the point A, TBC multiplied with Y, that will act in counterclockwise direction. Okay. So this RB into 1.25 that will be eliminated by TBC multiplied with Y, that is 2.165. Okay. Now we know the value of RB, so we can calculate. This is counterclockwise moment. So we can calculate TBC that equal to, that means by using the simplification, we will get the value of TBC, that is 4.33 kilonewton. Okay. If it is acting outwards from the point B, okay, then from the point C also, it will act outwards. Okay. So it will be compression in nature. Okay, this TBC, that will be compression in nature. Okay, so now we have to calculate the force in the member AC. For that, I am going to consider another section line, that is tension. That means to calculate the tension in the member AC, I am going to consider the another section line which cuts the required tension AC like this. And here there are two portions are there for the section line 2. Right side portion and then the left side portion. Okay. The right side portion of the section line 2, that is a considered portion. Okay. Here we are going to calculate only the tension in the member AC. If you calculate moment about A, the force in the member AC, that line of action of that force that passes through the A, so moment made by that force will be eliminated. Okay. So we can't get the value of AC. So it's better to take moment about B. Okay. Take moment about B and equate to 0. Here for the joint C, what are all the forces are acting at the joint C? If this is joint C, the vertical upward force or C that is acting upward, the inclined force with respect to the horizontal, it is acting at an angle 30 degree, that is TAC. Then the horizontal force, tension in the member BC or CB, whatever. Here I am going to take the moment about the point B. Okay, I'm going to take the moment about the point B. The BC, that we know that it is at a distance 5 meter. Okay, when you take moment about B equal to 0, this TCB, the line of action of that force passes through the B, so the moment made by the TCB, that will be eliminated. So only the moment made by the vertical upward force or C multiplied with this 5. Okay. And this we know that this is acting in counterclockwise direction, or C into 5 with respect to B, or C multiplied with 5. This is a counterclockwise moment that will be balanced by the moment or the clockwise moment made by TAC. As we mentioned in the previous method of joint, it may act upward or downward. That means outward from C or inward. If it is outward from C, it will act in second quadrant. Its vertical component will act upward again. So this moment made by the vertical component of TAC, that also will be in counterclockwise. So that cannot counterbalance this counterclockwise moment made by the RC into 5. Okay. So this TAC, that should be inward to the C, Okay. Then the vertical component TAC sine 30 that will act downward, TAC cos 60, sorry, cos 30 that will act towards right side. But here, whatever, with respect to the B, the TAC cos 30, okay, that line also passes through the B. So, moment made by the TAC cos 30, that will be eliminated. Okay. So, only TAC sine 30 multiplied with this distance 5 meter from the reference point B. TAC sine 30 multiplied with 5. Okay, that will be a clockwise moment. So TAC sine 30 multiplied with 5. Okay, this will be a clockwise moment. Okay, so that will counterbalance the counterclockwise moment which is made by the upward force RC. Now we can cancel this 5. So from this we will get the value of TAC that equal to RC by sine 30. Okay. So we will get the value of AC that equal to 5 kilonewton. Okay. Here you can see this TAC that is acting inwards to the joint C. Same way, it will act inwards to the joint A. So this AC that will be in tension. Okay, that will be in tension. Okay, so by using the method of sections, first we consider the section line 1, 1. We consider the left side portion, taking moment about C and equate to 0. We calculated the value of TAB. Then take moment about A and equate to 0. We calculated the value of TBC. Then we consider the section line 2, 2. And we consider the right side portion of the section line 2, 2. Taking moment about B equals 0. We got the value of forces in the member TAC. Okay. So now I'm going to do the force table. Okay. I'm going to do the force table. Okay. I'm going to discuss the force, finally the force table. Okay. First one, the serial number. Here the second one, that is members. Third one, magnitude of force. Here everything mentioned in kilonewton. So I'm going to put it commonly here. Then the nature of the force in the member. First one, the member, that is in the member AB. The magnitude that we calculated as 8.66. From this here you can see it tends to pull the member AB. So that's why this will be tension or tensile in nature. The second member, that is BC. From the calculation, we got the value 4.33 kilonewton. Then its nature. Here it tends to push the member BC. So it will be in compression. Okay. Then the third member, that is AC. As per the calculation, we got 5 kilonewton. And this also tends to pull the body. That means AC. Pull the member AC. So this also in tension. Okay. So finally, by using both the methods, method of joint and method of sections, we got the values of the forces in members AB, AC, and BC. magnitude, and also their natures. Okay. So I hope you all understand this video. In further upcoming video, we are going to discuss many numericals and many types of numericals on this topic, analysis of trusses and frames. Okay. By using method of joint or method of sections. Okay. So to watch more videos, don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver. Okay, guys. Thank you. Thanks for watching.